If you take a brick of juice and you drink it all, how does it become? Like this, I guess. And if you're wondering why, well, you'd say because the brick is empty. But do you actually know what the vacuum is? In everyday language, emptiness refers to the absence of any visible material. For example, a glass is said to be empty from the moment it doesn't contain any liquid. Of course, the glass is not really empty. In fact, it contains several trillions of billions of air molecules, which form a gas invisible to the naked eye, but which constitutes a real and concrete form of matter. In practice, it is strictly impossible to create a perfect vacuum, but today it can be strongly approached by modern techniques. That said, the most extreme laboratory voids are still far from empty, because they contain several billion particles per cubic meter. If you want an environment that is even emptier than those created in the lab, it is necessary to leave the Earth's atmosphere to travel in space. In the space between planets first, within our solar system, particles are very rare. There are a few tens of millions per cubic meter. Space contains so little material that it can be considered empty. This is a difficult concept for us because on Earth, matter is everywhere. Aristotle concluded, nature abhors a vacuum. So imagine the intergalactic environment, that is to say between galaxies, where we can find the most perfect vacuum, with on average only one particle per cubic meter. In the vacuum, certain properties which are familiar to us cease to exist. In fact, no matter means no sound, no temperature, and no pressure, because on Earth, atmosphere exerts a colossal force of crashing on the objects it contains. But if we don't feel it every day, that's because our body and most of the objects also generate an internal pressure towards the outside, which opposes it perfectly. However, imagine that we're interested, for example, in a plastic bottle, in which we will pump the air it contains. Now that it's empty, the bottle can no longer oppose the external pressure because it contains nothing. It will therefore be brutally compressed by the weight of the atmosphere. Imagine now that we can be interested in the vacuum not on our scale, but on microscopic scales. All the matter that composes us is made of atoms. The atom is like a solar system in miniature, with an extremely small nucleus around which electrons orbit as the planets revolve around the sun. That nucleus is nearly 100,000 times smaller than the atom as a whole, but it monopolizes 99.9% of its total mass by itself. The volume of an atom is therefore mainly empty, which means that all visible matter is composed of a majority of voids. To conclude, space vacuum isn't absolute. In fact, it is constantly filled with a multitude of virtual particles that appear and disappear permanently according to quantum physics. This is called vacuum fluctuations, but this is another mystery to discover.